Hi students, this week we'll be focusing on chapter 3, the final chapter of our y equals mx plus b book. Just as a reminder, before the break, you should have completed the cover and the introduction. Then, the first week of distance learning, you were working on chapter 1, working from equations. Last week, you worked on chapter 2, writing equations, given a table or graph. And this week, we're going to do linear analysis, looking at equations, seeing how we can categorize them. So we flip to the instructions on the back. You'll see that it says, list all 4 equations in slope-intercept form from the previous chapters. You may add more equations if you want. Show and explain how they compare with each other. So we're going to start with the first set of instructions. List all 4 equations in slope-intercept form from the previous chapters. If you recall, from chapter 1, 2, you created different equations to show how you changed the equation to a table and a graph, and how you changed the equation, the table and the graph to equations. So we'll use those 4. And those 4 are the following. Y equals -3/4 x plus 7. Y equals -1/5 x minus 2. Y equals -3x minus 9. And y equals 4/7 x plus 20 over 7. These are my equations that I came up from chapters 1 and 2. You definitely need to come up with your own equations. So with that said, when we have these 4 equations, we need to be able to categorize them as either proportional, increasing, decreasing, parallel, perpendicular, and how steep they are. And if you're having trouble figuring out how to categorize them, you can always add more equations to help you explain that. So when we look at these equations, let's start with proportionality first. When we're looking at equations that are proportional or not proportional, we need to look specifically at the y-intercept to determine that. So if I were to look at these equations and look at the y-intercept, the plus b part, when there is a y-intercept that is non-zero, it is non-proportional because it doesn't cross to the origin. When the y-intercept is 0, that means it crosses the origin, which means it's proportional. If we take a look at all these equations, all of them are non-zero y-intercepts. Therefore, they are all non-proportional. As a reminder, when you are doing your write-up, your y equals mx plus b book, it needs to be an instructional guide to show others your level of understanding for y equals mx plus b. So just doing all this math is not enough. You need to make sure you write it in complete sentences explaining how you know whether an equation is proportional or non-proportional. I also want to illustrate that this is not the only way to help determine whether they're proportional or non-proportional. You can also make graphs to show whether these lines cross the origin, or tables to show whether they cross the 0 on the y-axis. So all of these equations are non-proportional. If we want to show an equation that is proportional, we need to make one up. That's where it says right here, feel free to add more equations if you want. So we'll need to make up an equation to show that it's proportional. And as I mentioned a little earlier, that equation can be any equation that has a y-intercept of 0. So y equals 5x is an example of a proportional equation. Now that we have that, we're going to go look into increasing and decreasing. So if we want to look at increasing and decreasing, you can tell that by graphing each of these equations, all four of these equations. If you graph all of them, you'll see which lines are increasing and which lines are decreasing. I highly recommend that you create graphs also to show a deeper level of understanding of how you know whether equations are increasing and decreasing. That applies with proportional and non-proportional also. Making that graph will help make things very clear in terms of visuals. So if we're looking at increasing and decreasing, we need to specifically look at their slopes. So negative 3/4, negative 1/5, negative 3, 4/7. Okay, just by looking at the slopes, I can tell that y equals 4/7, x plus 20/7 is going to be increasing, and all the others are going to be categorized as decreasing. Okay, next we're going to look at parallel and perpendicular. So to determine whether lines are parallel or perpendicular, we specifically have to look at their slopes. And also to a certain extent, their y-intercept for parallel lines. So let's take a look at our first equation, y equals negative 3/4 x plus 7. This is my equation, and how would I create an equation that is parallel to this equation? I'll write down the solution, but I'll let you explain it in your write-up. A parallel equation would be y equals negative 3/4 x minus 5. And let's say I look at that same equation, y equals negative 3/4 x plus 7. How would I make a equation that's perpendicular to this equation? That example can be shown in the following way. Y equals 4/3 x plus 2. Remember what parallel and perpendicular mean. You can always look back at your work from previous linear functions, or you can do a little search on Google of how you can tell lines are parallel or perpendicular. To show a deeper level of understanding, recommend that you graph these lines and also find parallel and perpendicular lines for the other equations that you have. By showing more examples, it shows me that you have a deep understanding of what parallel and perpendicular lines are. So what I mean by that is, how can you write down what the parallel and perpendicular lines for each of these other examples? What would be parallel to y equals negative 1/5 x minus 2? And what equation would be perpendicular? Same with y equals negative 3x minus 9. What is parallel and what is perpendicular? And with our last equation, y equals 4/7x plus 20/7. As I mentioned, one of the ways that I can tell whether you're watching the videos is by writing down what the word of the week is on your assignment. So when you're doing your write-up, and I'll flash my write-up as an example. Here's chapter 1 write-up. Make sure you have your name at the very top. And next to your name, write down the word of the week. And the word of the week for this week is point of intersection. Point of intersection. This will be an important word for our next unit on systems of equations. Once again, the word of the week is point of intersection. Last but not least, we're going to look at steepness. So I'm actually going to keep it on the same page right here, steepness. And when we're looking at steepness, you want to organize them from either least to greatest or greatest to least steep. And in this case, I'm going to organize them by least to greatest. So looking at these four equations, I can tell that my equation that is least steep is going to be negative y equals negative 1/5 x minus 2, followed by y equals 4/7 x plus 20 over 7, then y equals negative 3/4 x plus 7, and lastly y equals negative 3x minus 9. I want you to think about, what am I looking at to determine what is the least steep to the most steep? There is a reasoning to that, and if you're having trouble seeing the steepness, you can always graph these equations and look at how the angle of incline for each of the equations are. Which one is very steep and which one is less steep. And you can go the other way around too. Very steep and less steep. That is all for this video. Hope to hear from you soon.